Welcome to the shop. Well, I got a new accessory for my CNC router. It's an automatic tool changer from CNC Depot and works really well. It's got pneumatic controls. I got some air valves in the control cabinet, and the pneumatic control operates the drawbar. So push the button, it releases. This is what's called a 30 taper tool holder. This is an ISO 30 taper. Let me show it a little bit clearer here, which is very similar to a CAT 30 or a BT 30. The difference is the way there's a couple of flats on here, and there's other small differences, but they're pretty much reasonably similar to other 30 taper tool holders. Anyway, it's held in place like that. And the advantage of this system is that now I can preset all of my tool lengths, so I don't have to measure tool length every time before making a cut or when I change a tool. So all I have to do is set the reference 0 for the part that I'm making, which in the case of this part is the center line of the rotary axis. And then the machine changes tools, looks in its tool table for the tool offset, and I can make a part with multiple different tools without having to continuously remeasure things. CNC Depot provided some little machined Delrin holders that hold the holders, so they're little kind of like grippers or something that hold these 30 taper tool holders in place. And I fabricated a little weldment here to hold these guys in place, and also made a little machined aluminum gripper so that when I'm tightening the nut, the thing stays in place when I'm tightening the nut on the tool holders. So here's my 4th axis with the part in place. I've already, let me go over here to a blank. I've already drilled holes, precise holes on the Bridgeport in the ends, and machined a little relief here on the end of the piece, because I don't want chip out on the very critical round end. When it finishes up, it's going to make a kind of a trumpet bell kind of shape on the end of this, and I want to make sure that the end ends up really nice. So I kind of like pre-machined a little bit of roundness there. So I'm going to reset the camera and see if I can get a cut to work on this thing. Okay, let's see if we can make this pig oink. Changing to the 1/2-inch round nose carbide tipped router cutter, running at 25,000 RPM, and I'm using a vacuum for dust collection. I tried at one time making a dust collection boot that went over the top of the motor and had a little fringe around the outside, and it never really worked really well. It was a pain in the ass, it restricted visibility, and I haven't come up with a good solution for dust collection yet. So the handheld vacuum kind of works, but hey, still makes a mess. I'm doing a 50,000th step over here. Every cut is taking 50 thousandths in the x-axis, and it goes slow, but it saves me time in sanding And so I consider the trade-off to be worthwhile. Kind of looks like I'm wasting a lot of wood here, and in earlier versions of the design, the end of the handle has a little kind of a trumpet bell kind of thing that is used to protect your hand against the hot aluminum of the part that it attaches to. And in the first version, I thought, why am I wasting so much wood? I'll just glue on a separate piece. Well, every single one of them broke off. A glue joint on the end grain of this wood is not very strong. So in this, I use a little extra wood, make it all out of one piece. Everything is strong and it looks good. So little bit by little bit. Dust collection on a CNC router is a problem for everybody, and unless you're cutting a profile into a flat panel, there's pretty much no way to control it on a complex cut like this. It's an African hardwood that I really like. You can probably see why I kind of pre-rounded the end, because if the cutter was just going all the way to the end normally, while it was still in a square shape, there's a chance that the corners could just chip out, and I certainly don't want to have a chip out here. Now that's probably enough vacuum. So now I'm switching to an 1/8 inch ball end tapered solid carbide router cutter to do the engraving. I'm doing a kind of a trick here. Real 4-axis software is expensive and I don't have it. So I kind of am lying to the cam system a little bit and telling it that the rotary axis is really the y-axis, and effectively treating it as a 2-dimensional or a 3-dimensional flat piece, and except for a scaling issue where the rotary axis obviously is scaled in degrees and I have to scale that to inches kind of by hand. Except for a scaling issue, it works really well. So there's waiting for it to slow down. I put a braking resistor on the VFD that controls the spindle. Without a braking resistor, it takes the spindle about 25 seconds to come to a stop after it's turned off. And with a braking resistor, it's able to slow to a stop in 5 seconds, which is far more tolerable. So now, last operation, going to be cutting a slot, and this is a slot for the lever that releases the magnets. So, cutting the slot, and then going to put a little drill hole here, just in case somebody might want to put a spring under the lever. I like the lever almost effortless, so it's almost imperceptible, but figuring that, well, maybe somebody might want a stiffer lever. So here we have the finished NQALHA handle, and looks nice. So thank you for watching. It's been fun.